Membrane for post-combustion CO2 capture, challenges and prospects. So while going to tell about the challenges and prospect on this aspect, I have another challenge to present my work within 10 minutes, 10 to 15 minutes, that is another challenge. So I'll try to make a smart presentation as far as possible to give you how we can use dense polymeric membrane for CO2 capture. So I am going to ask why we should do it for CO2 capture, because coal as a fossil fuel is a necessary part of any energy strategy. So we need to have a CO2 capture, and this is the picture which will give you how the coal is utilized and how the emission of CO2 per year is increasing day by day. So there are three possible options. One is oxy-combustion, pre-combustion and post-combustion. In oxy-combustion, what we do, we take a pure oxygen and then combustion of fuel is done. So you have typically obtained CO2 and water, and then if you just condense, you can separate CO2 from the mixture and you can sequester. And then pre-combustion, where you produce the syngas, CO and hydrogen, and then you make a water gas reactions, you can convert to CO2 and hydrogen. So you can separate CO2 hydrogen to get hydrogen, and then post-combustion. So I am just concerning on the post-combustion CO2 capture, which we can retrofit all the existing power plants. So these are the capture technologies, but there are a lot of work going on all of these technologies. I am only concerned about the membrane gas separation, whether it is possible or viable options. So these are major drawback of the conventional technologies. There are improvement on these technologies, and then in case of dense polymeric membrane, if we use for CO2 capture, we have the limitation of CO2 nitrogen selectivity, which is around 50, and the low permeance of the membrane. So it works only at low temperature, and if we look into the flue gas conditions, the temperature is around 120 to 130 degrees centigrade. The polymeric membrane, which is installed in 1980s, is the first membrane and the largest capacity membrane which separates CO2 about 700 million SCFD, standard cubic feet per day CO2 facility removal, and it has only selectivity around 20. So the conventional technology which use MEA as a solvent for CO2 capture, it costs around $60 per ton of CO2 capture, and which increases the cost of electricity about 85%. Suppose if we have if we do the CO2 without CO2 capture, if we generate the power cost is 1 rupees per unit, and if we install the CO2 capture plant using MEA, it will cost around 1 rupees 85 paisa. So US Department of Energy, they have set a target that it should not increase more than 35%. So to do that, so the capture cost of CO2 should be less than $24 per ton of CO2 capture. With this, there is another group which is my collaborator group at Biostate. They have done some techno-economic analysis, and they have said that if we do only air sweep membrane process, and if we want to sequester the CO2 which is separated by using the membrane, and that has to be compressed at 2200 PSIA for sequestration, then this membrane process, what property we need for selectivity and permeability. So with this, the summary of that work is that high CO2 permeance membrane we require, and low membrane cost and close to atmospheric operation can serve the purpose. So with this target, at a membrane price of $27 per meter square and CO2 nitrogen selectivity of 150 and permeance of 2000 GPU, can serve the cost of CO2 capture less than $24. So with this we have set a target of CO2 capture 110 to 130 degrees centigrade temperature it should work, and it should have a very high selectivity and permeance. So how to do this? We have taken a support layer polysulfone, and on which we have coated PVA PVP blend with the carrier. So we incorporate carrier to facilitate the CO2 transport. So there are some carrier which has different amine carrier, and it has a specific properties for enhancing the CO2 capture. And these are the reactions which takes place which enhances the CO2 transport properties through the membrane. So I am not going through this. What it does, the functional group amine carrier which will be incorporated in the polymer backbone, that will take the CO2 on the feed side and it will transport faster to the feed side, and it will transfer to the sweet side. And two different, depending on the bonding of the carrier into the membrane, it can have two different transport properties, mobile or fixed. The mobile will have faster transport properties of CO2. So these are how we synthesize the polymer solution, and then these are the cross-linking agent we use for cross-linking the membrane polymer, and then we cast on the polysulfone, and this is the typical morphology of the synthesized membrane. We have a skin layer at the top, and then we have a support layer polysulfone. And this we have published in Journal of Membrane Science, and these are the typical setup where we do the permeation study to see the characteristics of the membrane, what is the selectivity of different gases, and what is the permeance of the membrane. And these are typical setup, so I am not going to tell about details. These are the important results so far which has often reported in the literature. At Ohio State they have reported. This is with this composition of the PVA and different carriers at atmospheric condition 110 degrees centigrade temperature. This is how the selectivity and how the permeance is, and this is at a thickness of 60, and we have done at 42 micron thickness, and we have a selectivity more higher than that, and we have tried to extrapolate the data and tried to get these are our target and how much we could achieve. We have achieved around nearly 1300 GPU at 1 micron thickness membrane, and selectivity is much higher than the expected. So this is what we have done, and this is typical. If we go for commercialization of the flat sheet membrane, and the membrane module will look like this. Now I will skip on other aspects, so I will just quickly conclude. These are the take-home message. Enough scope for post-combustion CO2 capture using the polymeric membrane, using carrier, and we need to have a noble material synthesis using different type of carrier, and then techno-economic analysis also need to be studied thoroughly. Thank you for your attention. So these are the acknowledgement, and with this nice picture of IIT Guwahati. Now I invite questions.